Welcome back, students. In the previous class, we learned about light and reflection. So, we understood that when light ray falls on a surface and returns back into the same medium, it is called reflection. So, today we are going to learn about the special type of reflecting surfaces called spherical surface. Which surfaces? Spherical surfaces, and we'll simply call them as spherical mirrors. Okay, let's start the session today. So before starting, let me ask some questions that are related to the previous topic. So what is reflection of light? If anyone asks you what is reflection of light, it's nothing but the bouncing back of light into the same medium after striking a surface is called reflection. Okay. And write the laws of a reflection if anyone asks you. The laws of reflection, angle I is equal to angle R. This is the second law. And coming to the first law, incident ray, normal and reflected ray lie in a same plane. This is first law and this is second law. Keep that in mind. Okay, let's start the session. Firstly, spherical mirrors. Spherical mirrors. So a mirror is a reflecting surface. Let's imagine a mirror is a reflecting surface and that is a part of a hollow sphere. Let's say it's a sphere. I had taken a part of it, right? So this part is considered as a mirror. Okay, let's divide that part now. So I have taken that part now, right? This is one side. Let's get one more part. This is another side. So these type of mirrors, we'll call them as a spherical mirrors. A mirror whose reflecting surface is a part of a hollow sphere is called a spherical mirror. Right? We have two kinds of mirrors. One is a convex mirror and another one is a concave mirror. Concave mirror, convex mirror. Concave, convex. Right? So let's draw something which is nothing but every mirror has a one side it's a reflecting surface and the back side it is coated with silver. So we'll call it as a silver coated at the back. Right? For this mirror, reflecting surface is KO, concave, and for this, the reflecting surface is outward. So that's why it is called as a convex mirror. Right? So let's do an activity to understand it much better. Let's take a spoon. So you know spoons, right? Okay, let's say it's a spoon. Okay. So let's say this is the outer curved spoon. Step 1, outer curved surface of a spoon. So observe your piece. What do you observe? After looking into the spoon, we observe that there might be a small image. A small image is formed, and also you tend to see upright image is also formed. Small image and upright image. Don't get confused with the upright image. Upright means if you are like this, your image will also be like this. This is called upright image. It is also called erect image. Right? So suppose they have said inverted image, which means if you are like this, your image will be like this. Right? It is called inverted image. And it is called upright image. Upright or erected image like this. Right? So we'll discuss about these much later within detail. Right? So the outer surface of the spoon behaves like a convex mirror, right? Convex mirror. So let's say this is a spoon. So this outer surface behaves like a convex mirror. And what kind of image is formed over here? We got a small and upright image is formed. Okay. Let's see from this side the inner curved surface of the spoon. So when you see our face through this inner curved surface, you tend to find the image has formed. It has been enlarged. Enlarged means if your height is like this, then your image height is a little bit bigger, which is called as enlarged. Sometimes it is also called as enlarged or magnified. Both are same. Bigger images were scientifically called like this, enlarged or magnified. Right? So if you change the distance between you and the spoon, the image size may vary. Yeah. So the inner surface behaves like a concave mirror. Which mirror? Concave mirror. The outer surface behaves like a convex mirror and inner surface behaves like a concave mirror. Right? So keep that in mind. Inner surface of the spoon, this is called concave mirror, and outer surface of the spoon is called convex mirror. Let's discuss everything in detail about each and every mirror now. Let's start with the convex mirror. Sorry, concave mirror. Let's start with concave mirror. It's the most important mirror for you to understand it. So coming to the concave mirror, a spherical mirror. Let's say a spherical mirror whose reflecting surface is towards the inside of the sphere is called a concave mirror. A spherical mirror, let's say, if you extend this, it looks like a sphere, right? Spherical, it is a part of a spherical mirror, holosphere, right? A spherical mirror whose reflecting surface is towards the inside of a sphere, it is called a concave mirror. Let's try. So it's a concave mirror. For this concave mirror, I'm going to put something a little bit interesting, that is called as a, what do we call it? Silver coated at the back side, and which means it is silver coated here and it is a reflecting surface towards inside, right? So we could write like this. Keep that in mind. Concave, cave, cave said always like this. Keep that in mind. Now don't get forget about this. So reflecting surface is inside. So coming to the properties of a concave mirror, the reflecting surface is inward. Reflecting surface is inward. If anyone asks you, and converge is light rays. Okay, let's imagine and draw diagrams. Let me draw one diagram. I don't want to draw more diagrams now. You'll get a little bit confused about this. Let's draw an imaginary line, right? And that line, we'll call it as a principal axis. We'll call this line principal axis. Okay. So this line is an imaginary line that touches exactly at the center of the mirror, and that point we'll consider it as a pole. P for pole. So this is called pole of the mirror, right? So what is going to happen here is, let's draw one more point. Let's say this is called F. It is called principal focus. What do we call it? Principal focus. Now let's say we have a principal focus here. The object is far away from the mirror. What happens is the light ray comes and hits the surface like this. Let's say these two are the light rays. In our previous class we discussed about this. When it touches the mirror, what happens is it bends and converges exactly at point F. Yes, very good. Which means This concave mirror is an example for converging mirror. Concave mirror is also called as the converging mirror. Which mirror? Converging mirror. So concave mirror is an example for converging mirror. So keep that in mind. Converging mirror, right? Which is called converging mirror. Concave mirror, right? So coming to the real life example, let's say these concave mirrors are used in our day-to-day life. It was the most important 2 mark question. What are the applications, real life applications of concave mirror? If they had asked you, simply say these mirrors are used as a dentist mirrors, dentist mirror, and shaving mirror, okay, and also solar cookers. This mirror is also used in solar cooker to converge light rays at a concentrated one point. And headlights of the vehicles. Clear? These are the 4 important ones you need to remember. Concave mirror is used in dentist mirrors, shaving mirrors, solar cookers, and headlights of the vehicles, right? So let's move on to the next situation, and the next most important mirror, that is a convex mirror. Which mirror it is? Convex mirror. Okay. So coming to the convex mirror, the spherical mirror whose reflecting surface is towards the outside of a sphere. Reflecting surface is towards the outside of the sphere, and it is one side silver coated, which means it is not a reflecting surface now. So the reflecting surface is outside of the sphere, and it is called as a convex mirror. Which mirror? Convex mirror. If a mirror whose reflecting surface is inside of the sphere, it is called as a concave mirror. If it is outside, it is called as a convex mirror. Right? Okay. Let's say coming to the convex mirror. This convex mirror, the reflecting surface is outward. Okay. So let's imagine a situation. In this, when a light ray falls on the surface, what happens is the light rays gets diverges. Right? Okay, let's draw a straight line again. And that line we'll call it as the principal axis. And exactly at this point we'll call it as a pole. And what do we call it? We need to put the focus towards this side for the convex mirror. Okay. Let's say it's an object now. The light ray comes and hits the surface. Again it comes and hits the surface. What happens after touching the mirror surface? What happens? The light ray gets reflected. It means diverged away in different directions, which means those two rays are not meeting at any point. So we extend them backward, and they tend to meet at one point over here, and that point we'll call it as a focus, right? So coming to the concave mirror, what happens is the light rays they come and really touched at one point, but here they haven't touched really. You have to extend them backward. So here the reflecting surface is outward and the rays gets diverged. So this mirror is also called as the diverging mirror. Which mirror? Diverging mirror. So which mirror is called diverging mirror? If anyone asks you which mirror is called diverging mirror? Convex mirror. And which mirror is called converging mirror? Concave mirror is called converging mirror. Okay, let's imagine. It might be a little bit difficult to remember. So let's remember an acronym. So DOMAX. It's a word, famous word. DOMAX, right? So coming to the DOMAX, D for diverging, M for mirror, and X for convex, right? Keep that in mind. Diverging mirror is convex mirror, DOMAX. D for diverging, M for mirror, X for convex. Diverging mirror is convex mirror. So quite opposite. So converging mirror is, converging mirror is concave mirror. So quite opposite. If one is remembered, the other one is so easy. I hope so. So diverging mirror is convex mirror and converging mirror is concave mirror. Keep that in mind, right? So let's see the real life applications of this mirror. So coming to the real life applications, so these convex mirrors are used in rear view mirrors in vehicles, which means side headlights of the vehicle. Okay, not a headlights, side mirrors, right? So rear view mirrors in vehicles, and also security mirrors in shops. Security mirrors in shops, and also road mirrors at cars. Road mirrors. First one is rear view mirrors, and the second one is security mirrors in shops. And coming to third situation, road mirrors on the surface, so on curves. A curve it is placed with the mirror, so that which vehicle is coming, everything, right? Because this mirror is used at these places because it forms a very small image. Small images might be formed so that it can see much area, right? So that was the reason these mirrors are used here. So rear view mirror vehicles, because the backside, if any big vehicles or bigger vehicles might come, so those vehicles fit into this mirror, so that you could easily identify which is coming from the backside, right, while taking turns and everything. So coming to the security mirrors in shops, what happens is it covers a wide area so that every part of it could be easily visible. And also road mirrors at curves also. Clear? So let's move on to the important parts of a spherical mirror. Let's wipe and discuss about each and everything now. So let's start with concave mirror first. Concave mirror, yeah, and this is a reflecting surface. Okay, this is called a, and now this line is called principal axis, yeah, and exactly at this point, what do we call this point? We'll call this point as pole, P for pole. So we have drawn a line. Okay, let's start a point over here, and that point we'll call it as F, which is nothing but focus. Very good, focus. And the distance from focus to the pole is called small f. So it is called principal focus. So this principal focus has a specialty in concave mirror. The specialty is when a light ray comes parallel to the principal axis, after touching the mirror, after reflection, what happens is the light ray gets converges at focus. Yeah. So coming to the next situation, small f means focus or focal length. It is called focal length, which is nothing but the distance between pole to focus. Which is nothing but the distance from pole to focus is called focal length. It is represented by small f, right? So let's draw one more point here, and this point we'll call it as a C, which is nothing but center of curvature, right? We have cut a piece from a spherical mirror, right? In that spherical mirror, we have a midpoint, and that midpoint we'll call it as a center, and this is the center, right? So in a spherical mirror, what happens is from midpoint to the edges, we'll consider it as R for radius, which means the distance from center to the pole is called capital R, which is also called as the radius of curvature. What do we call it? Radius of curvature. And keep that in mind. Yeah. Focus to the center of curvature, the distance is again small f. Which means here pole to the focus is 10 centimeters. Then focus to the center of curvature is also 10 centimeters. Which means from this we could easily write a relation between R and F. Okay, let's write the relation now. So which means, let's say we have a mirror here. Let's draw a point, focus, center of curvature, and pole. Here to here it is called small f, and here to here again it is called small f, right? And here to here it is called capital R. So the relation between these two is R is equal to F plus F, which is nothing but 2F, right? 2 times of the focal length is measured is considered as the radius, right? So what about finding a focal length from the radius? F is equal to R is 2 is multiplying. If you send it there, it is going to divide. So F is equals R by 2, right? So here focal length and radius of curvature both are measured in length. So the units of these two are in centimeters or in meters, right? It just depends on the situation they had given. Yes. So R is equals 2F and F is equals R by 2. Keep that in mind and don't forget and don't get confused. And students always confuse about these two formulas, right? They might write F is equal to 2R and R is equal to F by 2, right? It's not a correct way. So remember the formula correctly. Okay. So let's move on. So P for what is called P? P for pole of the mirror, right? The center point of the reflecting surface is called the pole. The center point, exact center of the mirror. So what is called center of the curvature? The center of the sphere of which the mirror is a part. The center of the sphere of which the mirror is a part is called the center of curvature. It is represented by the letter capital C, right? C is called center of curvature. So let's say what is called capital R. Capital R is called radius of curvature. The distance between pole to the center of curvature is called radius of curvature, right? What is called principal axis? It's an imaginary line or a straight line passing through pole, focus, and center of curvature is called principal axis. We could also write the imaginary line that touches the points like center of curvature, focus, and pole is called principal axis. We could also write like this. What is called principal focus? So the point where light rays, let's imagine a point here. The point where rays parallel to the principal axis meet after reflection is called principal focus, which means the rays after touching here. Okay, let me show you. So here what happens is it's a concave mirror and the light rays coming from here to here and after touching the point, which means the parallel rays comes and meets at one point over here, and this point is called as the focus, principal focus. The point where rays parallel to the principal axis, it is the principal axis. This touches the points like center of curvature, focus, and pole, right? The point where rays parallel to the principal axis meets after reflection is called the principal focus. It is called a principal focus, right? For concave mirror, light rays meet at F, right? So coming to the concave mirror, if you consider the same situation and everything is same, what happens is coming to the concave mirror, what happens? This is point P, focus, center of curvature. It is not the correct way to mention focus and center of curvature here. So let's mention it here, focus and center of curvature towards this side, right? So which means the light rays is not going to meet clearly here because this is called, what happens is after touching this, the light rays gets diverges away, right? So these two lines are called incident rays, and after touching the mirror, these lines are called reflected rays. So they get diverged, right? Which means they haven't met. Which means you have to make them meet by extending them backward. Yes, for this purpose, what happens is the light rays appear to come from focus. Is that clear? The reflected rays appears to come from focus. Yes or no? Okay, let's see the relation between R and F. R and F. We have observed it already. R is equal to 2F or F is equals R by 2. So keep that in mind and don't forget. Right. So let's see a simple numerical. It's the most important numerical for 10th standard. So frequently they are asking this for 1 mark. So if they had given focal length is equals to 10 centimeters, how many centimeters? 10 centimeters, and r is equal to question mark. So what are you going to do now? So we know the formula r is equals to 2f, which means 2 into, in f place you need to put 10. So 10 to the 20 centimeters. Okay, centimeters, 20 centimeters is the answer, right? So that's it about the overall view. Did you get it? Okay. So let's recap what we have discussed up to now. So let's start with the first situation. What is a spherical mirror? A mirror whose reflecting surface is a part of a whole sphere. Let's say it's a sphere. The reflecting surface is a part. A mirror whose reflecting surface is a part of a whole sphere is called a spherical mirror. Which mirror it is? Spherical mirror. It might depend. What are the types of spherical mirrors? We have two kinds of spherical mirrors. One is a convex mirror and the other one is a concave mirror. Right? We have discussed these two also. So which mirror is used as a rear view mirror? So in rear view mirrors we need a wider field of view. For that purpose we need a convex mirror. Right? What is the relation between R and F? R is equal to 2F. Right? So for 2 marks they might ask this question like this. Write the difference between convex mirror and concave mirror. Right? Let's write clearly. Write the difference between convex and concave mirror. What are the differences between these two? If they had asked you, simply write, for a convex mirror, reflecting surface is outward. Reflecting surface is outward. For concave mirror, reflecting surface is inward. Right? So it converges light for concave mirror. What happens after touching? What happens is the light rays gets converges and meet at one point over here. For convex mirror, the light rays gets diverges away, right? And it can form real images for concave. It can form real images here, and it can form virtual images. What is called virtual? Virtual means the rays doesn't meet actually; they appear to meet at one point. Yes or no? So convex mirror can form virtual images, and concave mirror can form real images, right? So for applications like why are concave mirrors used by dentists? So we have discussed that concave mirrors are used by the dentist. Why are concave mirrors are used by the dentist means because they produce a magnified image. If the teeth size is like this, they can actually see the image is much larger, right? Which means the magnified image of the teeth. Then the object is when the object is placed very close to the mirror. So when the object is very close to the mirror, what happens is the object which is seen on the mirror is a little bit larger, right? So doctor can treat it very carefully because the image is much bigger, so it can see much clearly. So that was the reason the doctors use concave mirrors, right? Only the dentist manner. Okay. So that's it about the oral concept. For tomorrow is the most important class, right? Because we are going to deal with the spherical mirrors and the diagrams that are related to here. Clear? Which means concave mirror ray diagrams. So let me complete the concave mirror ray diagrams in one session, which means we have 6 diagrams and also set of rules. We have 4 types of rules. If you remember those 4 rules, then we are going to remember these 6 diagrams, right? And also we discuss about the image formation in different kinds, right? So that's it. Thank you.